IP6 is not widely implemented within organizations as yet, but it is used in certain applications, for example, direct access. Benefits of IP6 include an increased address space. There are 128 bits in an IP6 address as opposed to 32 bits in an IP4 address. That's a lot more room for maneuver. It provides for an improved routing experience. This is because of the structural nature of addresses. IP4 implements a flat system for routing purposes. There's nothing that distinguishes where in a network a particular device exists based on its IP address. Sure, you can see that it's a host in a given subnet, and you can see what the network address is based on default classes, but beyond that, you can't tell anything. An IP6 address contains information about what network and what subnetwork and how that ties into the rest of what's going on in the internet. It provides for a simpler configuration. With IP4, you have a choice between manually configuring a device or using DHCP. In IP6, you can use DHCP. You can also manually configure the addresses. But in addition, you can use automatic configuration from a router device. It's called stateless auto configuration. It provides for better security, better real-time data delivery. But there's a bit of a steep learning curve, and perhaps one of the biggest difficulties is getting to grips with the IP6 address format. As I mentioned, IP6 uses a 128-bit address. Now that's a huge number to represent in binary. It's hard enough looking at a 32-bit number for an IP4 address in binary. So 128 bits is not represented in decimal even, it's represented in hexadecimal. That significantly shortens the numbers and makes it easier to work with. But hexadecimal is not a natural numbering system for a human being. We're okay working in decimal, and I guess we can get used to using binary. But hexadecimal takes a bit of getting used to. The first three blocks of an IP6 address in binary might look like this. Now that's not going to be easy to remember, and it's also easy to get wrong. So we convert that to hex. That's a little bit easier to remember. It's still quite long. Let's have a look at an entire address. So you can see even trying to remember all of that information is significantly difficult. It's not terribly difficult, for example, remembering you're in network 192.168.1. That's fairly simple. But remembering you're in network 2002, 0db5, 00001d45, etc. becomes quite problematic. So we can use zero compression. In zero compression, we take out the leading zeros. That shortens the address still further. There's a whole block of zeros that are here, and those are removed entirely and replaced by double colons. Now you can't do that several times. There's another block of 000s over on the right-hand side there. It's not possible to remove those as well, otherwise it becomes difficult to interpret the address. That zero can be removed, but that one can't. For the exam, perhaps the most significant thing for you to understand is the different address scopes and types. Now these are very similar to IP4, but they use a different terminology. We understand in IP4 that you can have an automatically assigned address through DHCP, and that will be a private address. We can also use a PIPA, which is an address that starts 169.254. That's used for local routing only. It's a sort of a failback situation. And then we can have public IP4 addresses. You can also use multicast addresses to communicate with different devices. The same is true with IP6, but the terminology is slightly different. A unicast address can be one of the following: a global unicast address for use on the internet, a unique local address for use locally, and a linked local address, which is similar to the 169.254 address. You can also have special addresses and addresses for compatibility or transition. In addition to unicast addresses, which are assigned to interfaces on individual hosts, we can also support multicast addresses. Multicast addresses, as in IP4, allow you to communicate with several devices simultaneously and are useful for communicating information to several hosts, for example, software deployment. And anycast is communicating to any device. As with IP4, you're going to need to group your devices into subnets. A prefix is used to identify the subnet in IP6. It's a very similar sort of a process that you see in IP4. Although an IP4 subnet mask is a decimal number, 255.255.0.0, Actually, that can also be expressed as /16. In other words, the first 16 bits of the 32-bit address is the subnet address or network and subnet address. Similarly, in IP6, we can use the same system. So the number of bits in the prefix uses a similar notation to classless interdomain routing that we see in IP4. So here we have 2002:db5:/48, telling us that the first 48 bits of the address represent the network and subnetwork. You can identify the type of unicast address by its prefix. So a global unicast address has the prefix of 2000:/3. A unique local address has an address prefix of FD:/8. And linked local addresses have a prefix of FE8:/64. To configure an IP6 host, you must assign each device an IP6 network configuration which is unique. You can do that manually. Most hosts are assigned multiple addresses, a linked local address and a unicast address which is either global or unique local. You can also configure automatically by using stateful auto-configuration, in other words, a DHCP version 6 scope on a DHCP server, or stateless auto-configuration, where router announcements are used by hosts to determine the appropriate IP6 configuration. In other words, they listen to packets coming from the routers, see what network address is configured within those packets, and use that network address. They then use a mechanism to determine a unique address within that network. Stateless addressing, as I've just said, relies on router advertisements, and the process is as follows. Firstly, a client creates a unique link local address. It uses this to discover routers on the network. It then determines the prefixes, in other words the network IDs, configured on any discovered routers, and applies those prefixes locally. It will then contact a DHCP server to obtain any other IP6 configuration information. Now, whether or not it performs step 5 here is dependent upon if the managed address configuration or other stateful configuration flags are set. These are IP6 configuration parameters, I suppose. If both flags are 0, both flags are 1, the managed address configuration flag is 0 and the other stateful configuration flag is 1, the managed address configuration flag is 1 and the other stateful configuration flag is 0. So these are the 4 possible permutations of those 2 flags. And remember, only if the managed address configuration or other stateful configuration flags are set on, or 1, will it contact a DHCP server for further configuration. If it contacts a DHCP server, it will apply DHCP version 6 settings. This graphic helps explain that. That's the host using a local configuration, listening for announcements, applying the prefixes locally, and then checking local flags to determine if it needs to contact a DHCP server and obtain additional configuration information from the DHCP server. To manually configure an address, it's very similar to configuring IP4. You enter an IP6 address, you enter a subnet prefix length. You can also enter default gateway for routing purposes and one or more preferred DNS servers. As with IP4, the tools are pretty much the same. You can use network and internet settings, network and sharing center, network setup wizard, Windows PowerShell commandlets, the NetShish command line tool. So let's take a look at how to configure IP6 using the graphical user interface and how to configure IP6 using Windows PowerShell commandlets. Configuring IP6 is really not all that different on Windows 10 to configuring IP4. You use the same tools with pretty much the same syntax if they're from the command line. Let's start out by looking at this graphically through a network and sharing center. As before, we open up the adapter settings, right-click the adapter we want to configure, choose its properties, and then this time click on Internet Protocol version 6 and view its properties. At the moment, it's obtaining an IP6 address automatically. Now, although we have a DHCP server on this network, it's not allocating IP6 addresses. There are no IP6 address scopes set up. So it's going to use the equivalent of an APIPA type address, a locally routable address, something that will only work on the local subnet. To give a manual address or to assign a manual address, I click use the following IPv6 address, and then in the IPv6 address field I type an appropriate IPv6 address, specify the subnet prefix length. As you will remember from the session, the length of IPv6 addresses is considerably greater than under IP4. And then if I want to configure a DNS server, I can do that here. So click OK and close again. And then if I open up a command prompt, again I'll open an elevated prompt, even though that's not necessary, and type ipconfig, we can see that there is an IP6 address listed. That's the one we just created. The link local address is the one that was being allocated automatically through an automated local process that doesn't require a DHCP server. So we can also configure IP6 through Windows PowerShell. Open up a PowerShell window. And we'll use the same command, new net IP address, as we used for IP4, but this time we're specifying the address family as IP6, and we're entering an appropriate IP6 address and a prefix length. It's reconfigured that for us. You can see that it's added the address which ends in 1234. And as before, we can use the ipconfig command to view the configuration. As you see, as with IP4, the new net IP address commandlet adds the IP address. We can use the remove address commandlet to get rid of it. We can also use the get net IP address commandlet to view information in a similar way to ipconfig. And we can also use the get net IPv6 protocol commandlet to find out a bit more about what's happening with IP6. So the process of configuring IP6 is very similar to the process for configuring IP4. You can use the same tools, you can use the same interface. As with IP4, you can also obtain an IP configuration automatically by configuring IP6 here to obtain an IP6 address automatically and to obtain a DNS server address automatically. Clearly that requires that there's a DHCP version 6 scope set up somewhere for it to obtain its address from, although it's rather more complex than that, as we'll discuss in a later session. Routers can also allocate addresses. So there we are. So in the demonstration you saw how to configure IP6 using the graphical user interface and also by using Windows PowerShell.